Right. Thank you all for another Open Team in-depth, for joining us for another Open Team in-depth session today. It's my pleasure to have Steve Rosenwig join us to present all the work they're doing in the field this season. So, and with that, take it away, Steve.
All right, thanks, Dorn. So I'm Steve Rosenzweig. I'm a soil scientist at General Mills. I've been here for about a little over 2 years. Prior to that, I was doing my PhD at Colorado State in soil and crop sciences, studying soil health and economics of agricultural systems that are including more diversity, more cropping system intensity, that sort of thing. So I'm part of a really small but mighty team at General Mills that's leading all this work. And I'm going to go through a lot of it today. Certainly not all of it, but kind of a good balance of trying to give a sense of the breadth of what we're doing, but also dig into some of the methodologies where we've had some of those discussions within Open Team. So just a quick high-level overview about General Mills. We've got a lot of different brands with a lot of different types of ingredients in them. So, a lot of cereal, a lot of yogurt and dairy. So we own Yoplait and Haagen-Dazs globally. I think, you'll see a lot of these type of ingredients reflected in the work that we're doing. This is sort of going to serve as the overview of what I'm going to talk about today. This is just a slide I put together for our internal team to talk about what it is we do. But I'm going to just briefly mention some of the critical challenges that we're focused on. Then talk about our regenerative ag commitment and how we define regenerative ag and what we're doing to meet that commitment. And then talk about what regenerative ag is very briefly, and then get into the work that my ag research team is doing, and also work that's looped in with our global sustainability team on regenerative ag to both drive adoption and measure outcomes. So I probably don't need to go through this with this audience. We're losing soil biodiversity, there's economic pressure on farmers, and the climate impact of ag continues to go up. I always like to share this climate impact graph just because I think it shows, this is 10 years old now, so I imagine this line is even steeper, but it shows the magnitude of the work to be done here. We need, we don't necessarily need just incremental improvement. We need a complete change in the trajectory of the line. And so, this is the global greenhouse gas footprint of ag, and this dotted line going down is where we need to get it to be to avoid some of the worst climate scenarios. Here's our greenhouse gas footprint at General Mills. We have a goal to reduce our emissions by 28% by 2025. And ag is 50% of our footprint. So this is really where most of the work is being done to help meet our greenhouse gas commitment. We also have some stuff going on renewable energy and all that, packaging, but we're really kind of betting the farm on the farm, as one of my colleagues says. We do have all these other sustainability commitments, but the two specifically that I'm responsible for and our team is working on is this greenhouse gas reduction commitment and a regenerative agriculture commitment, which I'll talk about, where we've pledged to advance regenerative ag on 1 million acres by 2030. So what is regenerative ag? First off, I think there's a ton of definitions out there of what it is. And I'll share General Mills' definition in just a second, but I think one thing that unifies all the definitions is really that it's a set of principles that any farmer, whether they're organic or conventional, can implement to improve their ecosystem. And so I think, this is, one of the more commonly agreed upon facets of regenerative ag as a definition. The theory behind why it works is that it repairs and enhances these ecosystem processes, for example, the water cycle, which you can see here. But it also enhances and restores the nutrient cycle, pest disease cycle, carbon energy cycle. This is sort of the theory about how it works. It enables farmers to, support production with fewer inputs and greater resilience in their operation. So here's General Mills' definition. This has a lot of implications for the work that we do here. So our definition is regenerative ag is agriculture with measurable outcomes that protects and intentionally enhances natural resources in farming communities. So so it's not traditional kind of sustainability where we just, we're trying to keep things as they are. It's really about improving these 4 outcomes. We actually just are adding water here. We're in the process of kind of doing that, but I think it's okay for me to share now that, water is our 4th outcome that we're trying to see improvement on. So if a farmer is improving in these 4 areas, then that's what we'd consider regenerative, whether they're getting there through organic or conventional or however they're getting there. It's these outcomes of interest. So, and please stop me at any time if you guys have any questions. I'm going to cover a ton, so just stop me where you have a question. So I'll first talk about how we're driving farmer adoption of these principles. We're really trying to get these principles in the hands of farmers in our key sourcing regions. And so this is where our pilots currently are to drive this adoption. So we're setting up programs in each of these key regions. And these regions reflect a key ingredient or set of ingredients for us. But, we're largely working through commodity scale infrastructure, especially like in the Southern Plains for wheat, where, we're buying from Elevator, like, an aggregator that's aggregating the wheat across this whole region. So we're not necessarily direct contracting. We are in some cases, but we're not, we've really taken the focus of place-based approach to where we're going to try to influence the way agriculture is done in these entire regions, in the hopes that we ultimately affect farmers that supply to us. But we're not currently building out that sort of direct farmer relationship. So really the goal of these pilots is to drive farmer adoption of regenerative ag in these key sourcing regions and to measure those environmental and economic outcomes that we're interested in. And this is what a pilot looks like. This is sort of the formula for a pilot, where we've got education. So we're sort of airdropping these soil health academies, which are these 2- and 3-day workshops in each of these regions, where the farmers are getting a grounding on regenerative ag, and they'll bring in local farmers that are practicing regenerative ag, and we'll do a field day, or if it's in the winter, we'll have a classroom session where the farmers really talk about what it is they're doing and what the effects are. After we also go through our suppliers to recruit for those academies. So we're bringing in farmers that we know supply to our suppliers in some cases, but we also open it up to the broader public. So if there are farmers interested in regenerative ag, they can come as well. From those academies, we select a subset of farmers to receive one-on-one coaching for 3 years. And so each of these farmers is paired up with a coach who's most often a local farmer as well, that's been doing regenerative ag successfully and is passionate about teaching and mentorship and education. And so they basically have, individualized support for their unique farm for 3 years to help them create and implement a regenerative management plan on their own. These coaches aren't going in and handing them a plan to implement. It's really, they're guiding the producers themselves to come up with their own plan, because all these farmers that are in these programs are very different in where they're starting from, and they have very different types of operations. So it's important that they create their own goals, and this coach will help them get there. The third component is to build community. And, this is, as I'll talk about at the end, one of the challenges, but also, one of the big successes, I think, in what we're able to do is these farmers, a lot of them feel like they're the only ones in their area doing any of this sort of stuff. They get called crazy by their neighbors and get calls like, what the heck are you trying to do out there on that farm? So it's really nice to have a supportive community of other farmers all going down this path with you. So, we have Facebook group. We're learning a lot about, what social networks are preferred by different demographics of farmers. So older farmers actually wanted a WhatsApp group. So we've made that transition, but we're also doing, coffee shop meetups and field days. And really trying to build community between these farmers going down this regenerative path, and so that they can learn from each other. I think we know that farmers learn best from other farmers, and so that's really what we're trying to facilitate. And lastly, I'll talk a lot about all the soil, wildlife, and economic assessments that we're doing to really see if we're improving. Really, the goal of these programs is to drive positive impacts in these regions. And so we want to be able to measure those impacts, which is a lot of the scientific work that we do. And we're also in the Southern Plains pilot, we're also piloting the ecosystem services market. So where we'll actually be paying farmers for sequestering carbon, and we have local water quality partners that are investing with us to purchase water quality credits as well. So farmers can stack these different types of ecosystem services on a given acre. And so we are one of the first pilots for this market. And so, a lot of the protocols are still under development. And so I'll talk about what we're doing this year, but just know that it's likely to evolve over time. So it's not a representation of where ESMC is as a whole, but it's, kind of what we've settled on this year in the pilot phase. I'm just going to give kind of just a quick zoom in to each of these pilot regions, just the Northern and Southern Plains. I won't go into dairy too much. But in the Northern Plains, we've got 45 farmers that are all receiving this one-on-one coaching and are part of this program. These sites, so each farmer has dedicated one study field where we're going to be doing all of these measurements on soil and biodiversity and economics. And largely that's a bandwidth issue. We don't have, a million entomologists that can go out and collect samples on an entire farm, but we can look at a single study field per farm. And same thing for economics. To get around the privacy issue of understanding, we don't necessarily want to understand whole farm economics. I mean, we would, that'd be nice. But to avoid privacy issues, we've really only asked farmers to provide economic data on one field. So the different symbols here represent, there's farmers that are conventional, organic, or both. So that's just what the different symbols denote here. So I think it's kind of a unique program where we've got organic and conventional farmers all together. So that's the Northern Plains. This is what the Southern Plains program looks like. So we've got 24 farmers in the blue there. These are the farmers receiving the one-on-one coaching, the regenerative ag program. The green farmers out in Western Kansas, those farmers are part of the Soil Health Partnership program. So we've partnered with Soil Health Partnership to do these on-farm experimentation trials with, cover crops or no-till or some soil health practice of the farmers choosing. So I'm really going to only focus on the blue farmers here for today, but those Soil Health Partnership farmers are also going to be piloting the ecosystem services market, and will also be piloting payments for those services. So that's a little bit about our, the ingredients that we're employing to drive farmer adoption. And, the bulk of what I'm going to talk about here is largely about how we're measuring outcomes. Like I said, the driving the adoption of these principles is in service to driving these positive environmental and economic benefits on the landscape. So just quickly refreshing on the outcomes of interest. I'm still trying to think about what a water quality protocol looks like in these regions. So if you have ideas, that'd be great to know if other people are doing this. But I'm mostly going to talk about our soil health, biodiversity, and farmer economics protocols. So here's again the outcomes. Also, supply chain resilience is something of interest. So for soil health, I liked how Chelsea yesterday established the goals of the measurements. And really our goals are to establish baselines and monitor change over time in these pilots. So like I mentioned before, each farmer has one study field per farm. And we're really trying to see where they're at today and monitor that change over time. I hear a little bit of background noise. If somebody can make sure you guys are muted. Thanks. And so each farmer has one study field where we're tracking soil health. One of the great things is that we also have some data on field history for each of these farms. And so using the natural variability between the farmers, we can potentially start making some conclusions after year one on the impacts of different practices on soil health to date. But really, you know, the goal is as these farmers develop and implement these regenerative management plans, we want to track how soil health is changing. Secondly, we want to determine the effect of regenerative management systems on soil health and carbon sequestration. So, you know, most studies that are done in a university setting or, you know, at long-term experiment stations, they might be tweaking one or two things like, you know, the crop rotation or cover crops or a tillage regime or a fertilizer trial. In reality, these farmers are changing everything at once. And so what I think we're learning from the literature is really it's the synergy between these soil health principles that ultimately results in the biggest change in these outcomes. So we want to understand how these management systems relate to soil health and carbon sequestration. We might not necessarily be able to pick out the effect of no-till, for example, but we will. Our treatment is regenerative systems management. We also want these data to inform farmer decision making. That's been a challenge, I think, as you'll see later. And we also want to assess these relationships between soil health and other ecological outcomes. So water, insects, birds, you know, try to see these multi-trophic level interactions that are happening on the farms. And so here's the properties that we're measuring. So we're measuring soil organic carbon. I'll talk more about the protocol for that. But we're doing that to a meter deep. All these other soil health properties we're measuring to 15 centimeters. And we just picked 3 randomized locations throughout the field to do those soil health tests. Soil organic carbon is much more in depth, but we're gonna, you know, be going back to those same points in space over time to track soil health changes. So we're doing agrostability, POX-C, which is active carbon. We're doing single ring water infiltration, penetration resistance. We're looking at PLFAs, doing the Haney test, and we're also sending Greg from our size is getting spectral signatures of all of our soils. They're doing the underlying tech for like quick carbon, and so hopefully we'll have some spectra for all of our carbon samples. Just quickly on soil health reporting. So this is what the farmers get. So they get a soil health report directly from the lab, directly from Ward Labs. Ward is interesting. They have these kind of criteria, these scales where, you know, if you're in this range for this property, it's very poor, slightly below average, or good. You know, I'm not 100% confident in those, and some of the descriptions of some of the metrics, I'm not quite sure if we know all that much about what they're telling us. But anyway, it's at least something. It's some information for the farmers to dig into. At the same time, General Mills, we've been putting together, showing the farmers where they are relative to their regional average. So we have kind of these 3 clustered regions in the Northern Plains. We have the Saskatchewan cluster, this Western Manitoba and North Dakota cluster, and the Red River Valley of Manitoba cluster. So we're showing the farmers how they compare with their regional average for all these different soil health properties. I'm going to dig into the soil carbon sampling and what we're doing. In the Northern Plains last year, really all we did was pick 15 samples per field. We looked at soil type maps. We wanted to make sure we were sampling in all the major soil types, but really it was mostly random allocation within the field. We did 0 to 10, 10 to 30, 30 to 50, and 50 to 100 centimeter depth increments. Basically what we're doing here is taking a Giddings probe with a plastic sleeve on the inside and just cap the entire core. And then we send that entire core off to the University of Missouri Soil Health Assessment Center. And they'll take a full intact core and characterize it. So actually, mark the different horizons and depth increments and then separate it out by the depth increments. And then they'll run bulk density and organic carbon on all the samples. And we had them do a texture on a third of the samples and nitrogen on a fourth of the samples. No real reason for that, other than the fact that texture and nitrogen are somewhat expensive. And so I wanted to just balance cost with utility of those assessments. In the Southern Plains, what we're doing this year, so we're about to start soil carbon sampling this month. And we're going to be working with Open Team and Dan Kane and others, I think on the phone here, to do a more detailed stratification. So, with multiple input layers, run a conditioned Latin hypercube stratification to stratify the field, and then allocate 12 samples per stratum for up to 3 strata per field. So potentially, we will be taking 36 samples per field, as opposed to 15 in the 15 random samples in the Northern Plains. We'll be taking potentially 36, in the Southern Plains. So it's a lot more in-depth sampling. Partly for that reason, we're not going to a meter for all of them. Decided to do, just balancing the budget a bit, to do 50 centimeters for everything at those depth increments. And actually, still some decision to be made about whether it's 0 to 15 or 0 to 10. I know within Open Team, we've been talking about 0 to 15 just to align with some NRCS soil sampling guidelines. So we might do that. But then taking the meter depth samples every 4th sample, because DNDC has the ability to model down to a meter, but there's not a ton of data that allows them to kind of extrapolate what's going on below 50 centimeters. So this data is going to be valuable from that standpoint. We're going to be doing bulk density and carbon on all the samples. Texture, nitrogen, pH, and phosphorus on a 4th of the samples. And so these samples are also going to be used for the water quality modeling protocol. So like phosphorus and pH and things like that are important for that from that standpoint. Another thing I think is actually valuable for other people within Open Team to consider is, one of our biggest questions is, how many samples do we need and what stratification approaches work the best? It's actually suggested to me by Mark Bradford from Yale to actually regenerate our sampling points on a subset of fields within each strata. So, we're generating 12 random sampling points within each strata. He suggested to regenerate those again. So we have 24 random sampling points. And in comparing those 2 sets of 12 to each other, we'll start to get a sense of what is our current uncertainty with this current method. So we'll be double sampling essentially 3 of our fields to determine what is the variability and uncertainty in our current approach. If we wanted to test different stratification methods, I think we'd have to do more of a high density grid sampling so that we could overlay different stratification approaches on top and see how well they get us to the true field level carbon stocks. That just ended up being a little too expensive, I think. And it's hard to determine exactly what density of samples you need to apply. So this is what we're doing. And I think, for everybody out there that's taking soil carbon samples, I think a good question to ask is, how do I broaden the set of questions I can answer with this carbon sampling? And so just doubling up sampling on a couple fields will allow us to ask more questions of the data.
Hey, Steve, this
Yep.
is Brooke. Can I jump in with a question?
Sure.
I'm wondering if you have an average field size for this, thinking about how would we make this, is this protocol applicable across all Open Team participants? I think there's probably a lot more uniformity in farm size amongst the farms you're working with on this and what their average field size is than we might have in our pool of Stonyfield farms.
Yeah, there's actually quite a bit of variability. I don't even have all the field boundaries in for Kansas yet, but on average, they're going to be, the range is going to be from probably 40 to 120 acres.
Uh-huh.
So yeah, I mean, I'm kind of assuming an average of 60 or 80 acres. But yeah, we'll know more. And you'll notice like it's not per acre, it's per stratum. So you know, that's maybe something I need to dig in more to, is like, do we need to take more samples in a bigger field, or does the stratification approach, will it just assign more strata for a bigger field if there's more variability, and then you end up taking more samples anyway, that kind of thing.
Yeah. Okay, that's helpful.
Yeah. So we're also working on a grant with Colorado State to separate out the carbon fractions into POM and MAUM, this particulate organic matter and mineral associated organic matter fractions. This is quickly emerging as kind of the, you know, one of the ways to really unpack what's happening in soil carbon accrual. I won't go too much more into that, but you know, there's models being developed on POM and MAUM now, as just opposed to total organic carbon. So we want to sort of understand what pools of carbon are accruing in these systems, and what are the ones that are really responsive to management. And we're also going to be piloting. So Christine Morgan developed a VISNIR soil carbon probe when she's at Texas A&M. We're going to be piloting that along with her and her colleague at University of Nebraska. So yeah, I won't say too much more about that, but pretty excited to try out some new technology that might reduce the cost of sampling. Any questions about soil carbon or anything soil related before we go on to biodiversity?
Yeah, this is Jeff Herrick. So there are a lot of folks, obviously, including some on our team, working on the VISNIR approach as opposed to the middle infrared. And it seems to me that and I'm not working in that sphere, but I'm very interested in it. The issue doesn't seem to be so much the probe itself, but rather the databases that are being used and the covariates that are being used then to make those carbon predictions, given background levels of mineralogy and background types of mineralogy and so forth. Are you guys actively working in that space, in the analysis space with Christine, or is this just kind of a probe thing?
So yeah, I mean, largely I'm relying on Christine for the analysis, and she's developed libraries that we are going to use to relate the spectra to the carbon values.
Okay.
The probe also gives
working with
density too. So
it gives what?
Bulk density as well.
The probe does. Oh,
yeah.
Okay.
So it's got a penetrometer on it, and you know, relating the moisture content that you can pick up from the probe. From the spectra, so they've got, you know, they can basically adjust they can adjust for the water content, but they can also use that water content in conjunction with the penetrometer readings to get at a bulk density estimate.
Okay, good. All right, and so you are working with local libraries. That's good to hear.
Yep. I don't think there's libraries for everywhere, but that'll be part of the, you know, if there's got a lot of feasibility in the field, then I think we'll look at how do we actually scale this, and library building will be part of that.
Yeah, Steve, while we're on that, for other folks, I think it's worth maybe providing a little bit more background on that probe too, because it's just a quick description. It's machine mounted and sort of sapphire crystal sort of system. I don't know. I think that folks would be curious just to hear a little bit more about it.
Yeah, I'm not probably the best one to describe it, but I know it looks like a penetrometer, and then like a, you know, kind of like a tube that has the VISNIR spectrometer in it. It attaches to a regular old Giddings probe, and so it goes into the soil. You push it into the soil. It can go down to like a meter deep or more, even, I think. And as it's going down, it's taking penetrometer readings and picking up the spectra as it's going down, and on the way up I guess it's reading the spectra. And I mean, that's basically it. I think it takes like a couple minutes to push it in, but you get a carbon stock estimate right there in the field without having to collect any samples. So that's about as much as I understand of it. I really don't know as much as I should about it, but I'm hoping to go out. And
We'll get her. We'll get her to do a session.
Yeah, definitely.
I was gonna say I want to hear more about this too. So.
Yeah, I mean, hopefully we can share some of the learnings with the team, and I'll have pictures from the field. Hopefully, if I can get out there while they're doing it. So, yeah, more to come on that.
Great.
Steve, Patrick Lawrence here. I at least what I've seen from the literature is that it looks to me like your required sampling density definitely, at least observationally, it appears to decrease as field size increases. Mm-hmm. So I'm wondering, first off, if you do derive any relationships there, if you would be willing to share that with our team, because I'd love to just see what you find. Even not necessarily the data, but just like a graph of what that relationship looks like. Mm-hmm. And then second of all, back to your comment about being able to relate management systems to soil health, and how there's a lot of confounding variables in how farmers manage their fields. And so it's really tough to figure out those relationships. It sounded like you were instead kind of going up one level of abstraction and sort of saying, okay, well, how does regenerative management relate to soil health? I'm curious, do you feel like you can define regenerative management clearly enough in order to actually to figure out those relationships?
Yeah, so to unpack the experimental design a little bit, we do have so we do, like in the Southern Plains, we will have 6 sites within this region of the blues here that are conventional farmers that are controls, so they're not changing their management over time. Mm-hmm. And we've defined those as farmers that do lots of tillage, synthetic fertilizer and pesticide use, no cover crops, simple crop rotations. So those should be relatively, that should be a benchmark on one side. And then on the other side, we're trying to find 6 incredibly well managed, like AMP grazed pastures to use as a benchmark on the other side. So perennial systems. And then in the middle, we have a lot of data on, and I'll talk about this in a bit. We are collecting very detailed management data for each of the study fields. So we'll have pretty good sense of the field history of all the fields. And then also for the next 3 years, we'll know everything that's happened on those fields. And hopefully much longer than 3 years. We've only signed the farmers up for 3 years, but the hope is that these farms can be more of a long-term monitoring stations as well. So we'll have conventional farmers that are not changing, these reference sites that are not changing, and then these farmers in the middle where we're hopefully going to track change over their baseline over time. And we'll have the practices to relate to those changes. But the experimental design is not to say, okay, every farmer is going to have a cover crop now, and we're going to see what the impact of that is. So it's more holistic systems level change in that sense, that we're not prescribing a practice or even a suite of practices, that it's really kind of different farmers are going to be moving at different paces.
Sure.
Let's put it that way.
Yeah. I mean, to be clear, it's not an easy question to answer, especially just thinking about the required sample numbers to actually figure out how individual or even suites of practices relate to soil health. So.
Yeah, and part of one of the big goals of the pilots are to build out the case studies for regenerative ag. I mean, a lot of these are going to be in-depth case studies to help drive adoption in the region. All this economic data, hopefully we can show that farmers are becoming more profitable over time, and dig into specific studies and tell those stories in the region to help drive adoption. So I'd say that's one big driver for the reason why we're doing what we're doing. it does limit our ability to make broad sweeping claims about the impacts of regenerative management, unless the data are really clear in that way. But yeah.
Cool, thanks.
Okay. If there's anything else on soil, maybe we can come back to that a bit later. But I'll talk about what we're doing on biodiversity. So we're looking at both insects and birds on each of these farms as well. And so again, the goals are to establish baselines and monitor change over time. Determine the effect of these regenerative management systems again. But biodiversity is also more so than soil impacted by habitat in and around the field. So, what is the relative impact of infield versus surrounding, infield practices versus surrounding habitat on the biodiversity that we observe in the field? So we're doing a bit of satellite imagery kind of analysis to understand habitat types in a landscape context. But one of my questions is, we talked about the principles of regenerative ag. There's really 5 of them. A 6th one was just added, which is to understand context. But my question here is like, do we need to have a 7th regenerative ag principle, which is habitat? Or is regenerative management enough to see the types of biodiversity improvements that we want to see? And just anecdotally, I mean, you talk to a lot of regenerative farmers and they say they've seen way more insects and birds and wildlife of all kinds on their farm than they ever had before. So that's partly what we're putting to the test here. But we also want to, develop conservation-focused management recommendations. I don't think I have any in here, but there's some kind of interesting small tweaks farmers can make just by understanding some of the life cycles of the various organisms living in their farm. We also want to understand these interactions between soil, plants, insects, and birds. We're also doing some vegetation transects too, I should have mentioned. Ultimately, we're doing this to understand if we're improving biodiversity through our regenerative ag investments in order to meet our 1 million acre regenerative ag goal. And so we need some indicator or some way of measuring biodiversity to see if it's improving in these sourcing regions, so that we can track towards our 1 million acre commitment. One of our big questions is, how do we scale our ability to monitor biodiversity? What species or groups of species might be an indicator of overall ecosystem health? Some of these broader questions about these specific ecosystems and what they're telling us. So I won't go too much into the insect methodology. Basically, it's just a transect in a field where we're doing sweep netting and identifying all the species in the sweep nets. And we're working with John Lundgren at Ecdysis to do this. And they're also taking soil cores and using Berlese funnels to see all the different insects living in the soil as well. So that's what we're doing for insect methodology. We have applied ecological services doing the breeding bird surveys. So these are some of the ecologists working with us. So we're looking at the species, behavior, direction, and distance from their observation point. The number of birds, the richness, abundance, presence of priority species in the study fields. And so they have, we have a list of the priority species, so like species in decline or species of conservation priority. So we're looking at how those, who's present in these fields essentially. And so we've really just got a baseline sample up in the Northern Plains so far, but we're going to be doing this in the Southern Plains as well. So this is what the breeding bird observations look like. So, they have 2 points in a field, and they're marking the distance to their point so they can understand what parts of the field or surrounding habitat these birds are using, and what they're doing out there. Are they breeding? Are they foraging? We've also, we're in the prairie pothole region up in the Northern Plains, so there's a lot of these infield wetlands. We have a lot of wetland birds, and there's like shorebirds up here. And And so they're also looking at, doing some vegetation transects in around these wetlands to get a sense of wetland quality, because we know the quality of those wetlands is really important from a conservation perspective. And like I mentioned before, we're also doing some satellite imagery on the surrounding habitat types to use as a covariate in some of the analyses to understand, how does this surrounding habitat impact what we find in the field. This is what some of the data looks like. I know it's a little hard to see, but we have these maps for every single bird that was identified, and there was like well over 100 different bird species identified. But this is for bobolinks. Each dot here is a farm where a bobolink was observed. So we had a pretty good distribution of bobolinks across our study fields, and they have the counts for these, and we can kind of see, you can tell our study region is it's right within the breeding zone of these birds. So this is one of the analyses that we're deriving from this. We can also, compare our different sites and look at, bird richness and abundance by site, and dig into some of these other management or habitat type covariates to understand what are some of the predictors of the biodiversity we're finding in these sites. They're also developing, conservation specific recommendations, and hopefully we can, put together at some point, like how to farm with birds in mind kind of thing at the end. We're doing a ton of work with infield sensors and satellites to try to scale up our methodology, our measurements. So, there's not enough entomologists in the world or wildlife ecologists in the world to measure biodiversity on 1 million acres. And so, really the regions where we're working is now it's like 16 million acres represented in those regions. So we need creative ways of scaling these methodologies up. And so we're looking at infrared cameras coupled with artificial intelligence to determine insect biodiversity passively in a field 24 hours a day. We're looking at using microphones to measure the total amount of biophony, the amount of life-related noise in a farm to understand, biodiversity, abundance, diversity, and how that changes over time. And we're also using satellites and models like DMDC. So we're working with Dagan a bunch to model changes in practices and changes in greenhouse gas emissions and soil carbon to scale up some of our soil analyses. So this is one of the most exciting, fun components of this work is really digging into these emerging technologies and using these technologies for things they weren't designed to be used for is pretty fun. So now for economics, really the economic hypothesis of regenerative ag is that as you restore your farm ecosystem and improve soil health, improve your biodiversity, that you can support your production with fewer inputs. And so that's the hypothesis that we're putting to the test here on one study field per farm. But and we're doing that with our size. So we've got, we had farmers filling out every management practice that they're doing in these study fields with these our size surveys. And so you can see all the different costs that we're tracking here, and ultimately net return. So yeah, I mean, there's going to be a lot of improvements to this technology coming this year. Hopefully that makes it easier. A good chunk of my year last year was spent on the phone with farmers, walking them through how to use this stuff. And oh yeah, you got to be on Wi-Fi, and here's how you log on to Wi-Fi, and stuff like that. So hopefully technology improvements, and also just hiring more people on the ground that can follow up directly with farmers, I think is going to be our strategies moving forward. And lastly, we want to aggregate up, economic resilience of farming communities. We want to eventually aggregate that up to understand how that impacts our own supply chain resilience. And so here's the hypothesis that I've crudely drawn out here, but we know that from year to year, within a given sourcing region for any particular ingredient, we have these huge year-to-year swings in yields and quality. And the idea is with regenerative that you smooth that out, where your lows aren't quite as low. And maybe you're not maximizing yield because you're not shooting for yield, you're shooting for profit. So maybe the total overall yield isn't going up, but that resilience and yield stability is, which is good for business. And so that's something I'm working on quantifying. There's a couple different technologies out there that I think have the ability to do this. But just, as an example, Dagan did an analysis of the, prevent planting acres from all the flooding this spring or past spring. And they found that fields that were successfully planted using satellite imagery, they found that fields that were successfully planted had longer number of years of no-till and cover crops and reduced till than fields that were prevented planting. So this is one way that we could potentially relate the adoption of these practices to resilience of our supply chains. And my hope is to ultimately put a dollar figure on like, what is a regenerative acre worth to the food system? So something I'm working on as well. So here's our outcomes, that main outcomes of focus. I didn't talk about water quality because I'm still trying to figure out what that measurement protocol looks like. But there's sort of a sneaky sixth one that's where it's still experimental, too experimental to call out that it's actually an outcome. But if you talk to any regenerative farmer, they swear that the nutrient density of their ingredients is going up. And as a food company, this is, we know how to market health outcomes to consumers. So obviously this is something that we're interested in, but there's not a ton of data out there. And so we're working with Greg at Our Sci, we have variety trials for oats, for example, all throughout North America. And so we're trying to build, a library, a database that has, relevant human health properties, what's the effective, what's the ranges of all these different varieties, geographies, and then, layering on the grain samples from our regenerative pilots, we can see where those samples fall within that, within the ranges for the variety geography. And we're trying to understand if those differences based on regenerative ag are medically relevant for people. So, we're just in the very early stages of doing this, but, just another project I'd call out that we're going to be helping figure some of this stuff out as well is the Colorado Conservation Tillage Association just got a soil health innovation grant, and they have all these they will have paired regenerative and conventional sites throughout the high plains, and they want to look at the nutrient density of those grains. And so if we can build industry standard ways of measuring nutrient density for all these various crops, that will allow us to start to unpack this question of does management and soil health ultimately relate to changes in medically relevant nutrient density. So just to summarize, I think some of what we've found so far, we've only been doing this for a year, so we don't have a ton of experience, and it's constantly evolving every year, as you can see. But some of our key challenges are how do we balance farmer data privacy with our ability to use that data for research? So sharing specific field boundaries or sampling points, lat longs, that sort of thing, has a ton of value, but it's not great from a farmer data privacy standpoint. So, balancing some of those things. Collecting, cleaning, QCing all the farm management data was probably the biggest challenge, and still is. We still have a lot of missing and not clean data from last year. How do we make the scientific results and the process of science meaningful for farmers? And so a lot of our farmers were upset that they didn't get to hang out with John Lundgren when he was out doing insects on their farm. Because John's like, I have 50 farms I need to sample, in a very short window. So he's just, trying to get it done as fast as possible. But how do we actually make time to involve the farmers in this process? How do we facilitate social network and farmer community building? You know, I was just like, you know, at the beginning of the year, I was like, what do we do? I made a Facebook group. There was a ton of involvement at first, and now it's sort of waning. So like, what's best practices for facilitating farmer networking? I think we can hopefully help to figure that out as a community. And then also, how do we amplify the impact beyond the farmers in the study? So we know that the farmers in the study are incredibly grateful for receiving all these free services and the coaching and the network and the measurement results. And I think we're going to see big changes in them. How do we amplify that impact to ultimately drive changes on the landscape? So that's it. I think we got a couple minutes for questions.
Thanks so much, Steve. That was great. And as usual, I've got tons of questions, but I'm going to let somebody else to jump in here for these next few minutes.
Steve, I have a question or a comment.
Sure.
Yeah, thanks. That was really, really cool. On your last slide with the, you know, helping the farmers get more out or more engagement with the science. Do you have any piece of the data collection where farmers are actually collecting it in terms of the field measurements? Because that's a piece that we have found has been really helpful, but was also a bit nerve-wracking to go from, you know, us collecting and controlling the data to having it be more of a community science protocol.
Yeah, we've been thinking about that. I think the protocol is going to get more streamlined over time. Right now, we're trying to understand, you know, everything that's out there. I mean, a farmer could definitely do sweep netting. It just seemed too daunting to try to coordinate that, at least for the first year. As we streamline the protocols, I think that's definitely an option. What we're going to do this next year to kind of balance the two is have a dedicated, afternoon and evening where the farmers can tag along with the samplers as they're going out and sampling, and they'll just basically, do a field walk, and John will be able to it'll be like a workshop during the actual sampling time, so that they can be involved if they want, and we'll have a couple opportunities for them to participate in that. So it's not actually them doing the sampling, but they can tag along and ask questions and be involved to the extent that they want to be.
Mm-hmm. Yeah, Franklin, I'm really glad you asked that, because I think, and Steve, for bringing up the community aspect and participation and the real desire, both from a farmer perspective, but also just from an economics perspective of creating protocols and tools to enable more engagement and peer-to-peer support and training in the field. So I think there's a lot of follow-up there to be doing. I really like your focus on that as sort of a challenge. I'm hoping that that's a big part of what we'll be working with Open Team in capturing that through the human-centered design process and through gathering best practices across different production systems on that social component. Mm-hmm. Other questions for the remaining minutes? Well, turn it back to you, Steve, to close out here.
Sure. Yeah, I think we're going to be learning a ton this next year. I hope lots of other people are as well. So I'm just looking forward to sharing that with this group and comparing notes and learning together. So thanks all for the opportunity.
Yeah, thank you so much for joining us today. And again, as always, we have I've taken notes in terms of several other follow-up topics that we'll want to flag for the spring. So we'll try to get those scheduled and posted here. So thank you all so much for joining.
All right, thanks.
Thank you.